Hello, today I would like to talk about the system we created as our backend application. Firstly, I would like to talk about the language we used. We used PHP as our backend language. We chose PHP because we wanted a multi-threaded application to be created for various types of users we will encounter. We thought of choosing Node.js. However, we wanted something that could work simultaneously with Nginx. So we are currently using Symfony framework in our PHP ecosystem. Let me show you the folders. We have the basic Symfony folder structure, which consists of bin, config, migration, and source. Um, in the migrations, you can see the table create queries. We use these migrations because we didn't really want to send in default queries, which would mean that you had to use these queries as you insert them manually into your database. So in this system, you have to add the SQL into the environment, and then you're free to call the migration setup command, and then the tables are automatically set up. So this really saves some time. And also we have an up command and also a down command, which really drops the tables. Um, most of our codes we wrote are inside the controller. Firstly, I would like to talk about the entity and repositories. We firstly created our project structure using the ORM, and then we converted all of it to be used with queries, which was really a good experience for us. We used these basic entities, which has functions like set name, get category ID, which is really used as a query generator in this case. And also we have repositories that we use to get our entity models, and we use them to automatically generate ORM in our application. However, we currently do not use any of these. All of our code consists of our controllers. Controllers consist of different routes we use. So let me just open one of them. Let me open this user controller. As you can see in comments, we will perform this function whenever there's a post request into this URL. After this post request, we are getting the request itself. This object has the query parameters, body parameters, and headers. We get the body parameters here, and then we generate a token which is used to authenticate users, and then we insert these tokens into our table. So here is one SQL we wrote. We are using Doctrine, which is generally understood as an ORM system of Symfony. However, we are using Doctrine to handle our SQLs that we wrote, and then we execute them, and in this case we are getting the last insert ID from this after this execution, and at here we are getting the results of the user we created. And also we put try and catch blocks in our requests to send in a default error message to our users. Currently we have the structure where we say status OK whenever the system is executed the queries correctly, and we say status is equal to knock whenever we catch an error. So let me show you the Postman collection that we created here. As you can see, we have 17 different requests in 4 different folders. Let me show you how we create an if user. So this is our IP address that we set up our backend service in. This is the port our Nginx is listening at, and this is the request URI that we are posting the HTTP request to. So out/signup, and we are using out/signup. So what happens here is we are sending a username, password, email, and phone number, and then we are receiving a token. So let us send. So as you can see here, we received a token. This token is used as authentication. We first tried using sessions and cookies as our authentication tokens. However, we wanted our REST API to be stateless, so we converted into a basic token structure. So what this is we create a 16-digit random numbers and letters, and we store it in our user table, and we check this token in most of our post, put, and delete routes. We are not checking it in user routes because you have to be signed out to create a user. So yeah. However, as you can see in our categories, you can really get all categories here, which is a GET request. However, you cannot send in a new category for this if you wanted to not send in a token. So let me show you here. New category, and the parent category ID is 1. Okay, so it will say there is no tokens or headers on headers. Let me send in the token that I received from creating a user. Here's a token that our system generated for me, and let me just paste it here. Yeah, as you can see, I created a new category. You can perform this action in different routes as well. However, I don't really have that much time, so thank you for watching.
Hello, my dearest professors. My name is Hıdır Doruk Kılıç, and I'm one of the developers for the Just Beat It project. I'm going to explain you the front-end part of the project, which I contributed the most. Okay, so let's get started. We used HTML, CSS, JavaScript, and Node.js for our front-end part. We used some other libraries like Bootstrap, jQuery, but not that much. As you know, our database and our backend server has already been deployed in the internet, so we can send requests to them. But how can we send requests? The browser cannot send requests, so we used Node.js for this part. In Node.js, there are so many libraries, as you know, and one of them is Axios. Axios is a library or a packet that can send requests to the specific URLs and get back responses from that URLs. Basically, it does that. For example, so let's look at the sign-up part. As you can see, Axios sends post request to the URL authentication sign-up to sign up a new customer. Okay, so our structure is like this, and in our Node.js file is in the oldest of the directories, and it's the front-end server for our project. I like calling it a control center. because our structure is like this. When a browser sends a request, say a sign up request, okay? So if our browser wants a customer to sign up our database, we send a data status JSON formatted file via WebSocket. By the way, we use WebSocket for the communication of our front-end server and the browser. We open a WebSocket server in the Node.js part and WebSocket clients in the browser part in necessary areas. For example, in the browser part, a client wants to sign up to our web page, so our browser sends data.status as a sign up variable to our front-end server. Front-end server gets this and starts to understand and sends a post request to this URL and sends the response back to the browser. Our structure is like this. Okay, so let's have a quick demo of what happens. For example, our front-end browser has an attribute named getAllProducts, which gets all the products from the database, from our server. When our browser wants to get all the products, it sends data as status via WebSocket to the server, and our WebSocket, once it gets the getAllProducts status, it sends a GET request to the server. And when server responds then with the necessary information, in this case all the products and their information, we send back this information, aka response, back to the front-end browser. Okay, this is basically how our front-end works. Let's run a quick demo to see what happens. As you can see, this is our project directory. We need to start a Node.js project in our directory, which is simply using node index.js. Now our front-end service is up and we are ready to go. So I want to start with the main page. This is our main landing page. As you can see, it's totally looking so professional, and with our copyright, login part, create an account part. When we make it smaller, nothing gets complicated, totally responsive. Okay, let's make a quick demo. Let's register an account. Name, I want to say Dork10, and last name Kilic. Email dork10@email. Phone number, let's make something up. Our username, let's make it dork10. Password, I'm gonna go with 12345. Gender, male. Once I submit the page, our front-end server responds with the status OK, and this username has been registered. As you can see, we have a very clean log in our front-end server, so that we can work so much cleanly. Okay, let's log into our account 12345. Okay, this is our profile page. As you can see, it is responsive. Now I'm not selling anything, so this is empty. My bits, I have no bits right now. This is empty, and sell an item now. So let's choose a name for our item. Dork10 first item, let's say. Minimum amount, I want to go with $0. I want to make it fitted for available for 1 hour. And description, Dork10 first item description. Okay, once I create that account, as you can see, status is OK. Your item has been successfully uploaded, and it gets our page refreshed. And now in the I'm selling parts, we can see our product, right? Dork10 first item description. Everything is looking good right now. So once I click this button, this product I get an update my item fast. Okay, let's update our item. Dork10 first item, let's say updated, and let's say updated. I want to go with $0, so I'm not going to do anything in here. And once I click the update now, upload successful. I'm selling first item updated. Okay, so this is an example for customer sign-in and editing a product. Let's sign out from here. Okay, I signed off and I want to log in with a different account, which I might call it admin and admin. We use this account for so many requests. There are so many products in here, as you can see, and they are all responsive, as you can see. And um, users can see the name, max bit for the given product, name, max bit for the given product. Let's make it bigger. Name, bit not given yet to this item, and so on and so forth. I want to give a bit to the Doruk 10's product. As you can see, there are so many products in here. We have our categories in here, but we have a search bar in here. I want to search for Doruk 10. Okay, let's go. Doruk 10 first item. This is the item we added. Check for the ID. It is the same as we added. So I want to make a bit for it. As it's 0, its max bit is 0 now. I want to go with let's say $20. Just bid it now. Your bid has been uploaded, and I say click OK. So my bid is up now, and I can see this in my profile page, my bids part, and in here I want to look for Doruk 10 for here. It's probably in the bags. Let's see name or no, name. I wanna search for yes, in here Doruk 10 first item updated, description updated, ID 117, and offer given to ID is $20. This is our admin page my bits part. So this is okay. Let's get back to the Doruk 10's account. For example, I want to give a wrong password for it and try to log in. Wrong password, we get an alert. And once we correct that password, no, there's no problem. I'm selling part, we get a bit, $20 from who? But let's see. There's a time to finish this bet, which was 1 hour, but I want to click to finish the bet, to call the bet off. Okay, so once I click this, we have a message, we have a winner. Here are the contact details: username admin, mail admin, phone admin, sold price $20. Okay, so this is our basic front-end demo and front-end parts. Hope I make it clear for you to understand. There are so many codes which I would like you to consider, but we have not all the time in the world, so you can look at them if you want. But just know that the most important part, in my point of view, the most important part is this control center in our Node.js for our data status. Once browser sends the status, our Node.js app gets the response, sends requests and gets response from our database server and sends it back to the browser. Thank you for listening to me. I hope you like our project front-end parts.
Hi, hello everyone. I'm Itan Salam. I take a part in this project as backend and DevOps engineer. In this part of the video, I will briefly summarize the normalization steps and also architecture of our cluster design. Now let's start with the normalization steps. In our database tables, we firstly had a base version in the first step. As you can see, every element of the database inside of just two tables. Everything's in here, that's too basic. And also you can see our functional dependencies. And in normalization step 1, we created table 1, which consists of user details. Table 2 consists of product information. And in the table 3 has a categories as well as the starting price of the offer. You can see our functional dependencies in here again. I will quickly skip them because they're too basics. And in normalization step 3, we divided our table 2 into two parts. We separated currency into its own table. We described the currency using ID, and we currently have a one-to-one relationship between the tables. Table 2 and Table 3 integrate this currency ID into their own infrastructure. In normalization 3, we divided our tables into 8 parts. Firstly, the user table consists of basic things like username, password, etc. In table 2, we store our bits. We have the date of the bid and current offer of the product. Table 3, as you can all see, is a relation table. In table 4, we have product informations. Table 5 is same with previous step. And table 6 just consists of category name and parent category ID. Here I just want to mention that what parent category ID is. Parent category ID means like parent of a node in a tree. For example, parent category ID for electronics is null, but parent category ID for laptops is electronics, just like trees. In table 7, we have the starting bit ID, currency ID, and the product ID. This has a one-to-one relationship with the product table, and table 8 is also relation table 2. And I just want to mention that blue keys means primary keys, and green ones means foreign keys. With the help of these normalization steps, we provided a greater overall database organization, reduction of redundant data, data consistency within the database, and a much more flexible database design, and finally a better handle on database security. That's all about normalization steps. Now let's take a look design of our cluster. Here you can see our cluster. Actually, our cluster consists of nearly all the elements for availability, scalability, and security. This is a monitoring server. There is gateways, which includes VPN servers, load balancing. There is a local network and public IP address. We divided everything. We use modularity in every step, and that's it. In my presentation, I will just talk about MySQL cluster, InnoDB cluster, because this is the key part of our cluster and directly related to our database performance and database architecture. And I explained all of the elements in our documentation detailedly. So in this presentation, I will just talk about InnoDB cluster. MySQL InnoDB cluster is a complete MySQL high availability solution. Each MySQL server instance uses MySQL group replication, which offers the mechanism replicate data within InnoDB cluster with built-in failover. In the case that a server instance fails unexpectedly, this cluster immediately reconfigures. The primary server instance is replicated in many secondary server instances. If the main fails, a secondary is elevated to the primary automatically. This is detected by MySQL router, which redirects client applications to the new primary. And the following benefits has been provided by the help of the database architecture. What are the benefits? First, let's imagine, in the event that the master node fails, the system will automatically fail over. Servers in the same group will automatically elect a new master. And second benefit, with the help of the synchronous replication in general, we may well be sure that committed data will not be lost if the master node fails. And lastly, by sending read operations to the replicas and leaving write operations to the primary server, the application can handle more requests. This is too important our performance. Now let's show you a quick demo. Now I will try to connect my Zabbix server. Here you can see address of the Zabbix server, and this is a local address. We cannot access it right now because I did not connect my VPN certificate. I did not activate it. Here, let me try. So as you can see, we cannot connect it. Now I will connect my VPN certificate, which I created for this project. My username, my password, and I connected to my VPN. Now let me try again. Here you can see we cannot access it easily right now. This is our monitoring server, a Zabbix server running in the background continuously. Let me show it. Here you can see a Zabbix server is running in the background. Normally in the Zabbix server we need a database in order to store all the logs of the cluster inside it. But in this architecture I did not use a database inside of the Zabbix server instance. Instead of that, I use my InnoDB cluster. This cluster take part of storage for all cluster. For example, as I mentioned, I did not use a database inside of the Zabbix server. I use a cluster. How did I do this? I will show you directly. Let me copy that password in order to access the database. Now, as you can see, I will directly access to this database, primary database instance. How can I do this? This is the IP address of the router, and this is the port address in that I mentioned in here. So if I try to access it, it means we will go through this MySQL router and this this port, and we will reach the primary database. Let me see. We are in. Let me show our databases. Here you can see our database for Zabbix server inside of this cluster. This cluster consists of much more database than Zabbix server. I printed them out in here. This is this terminal page represent this primary database instance. Here you can see there's much more than just Zabbix server, but I give privilege for this instance just for Zabbix server, and we can just reach that Zabbix database and we can just write and read from it. My presentation ends in here. Thank you for listening. Have a great year.